Hello, g'day, and welcome back to episode 12 of Whether or Not. I am Stella Q, and today, together, we're going to scrape off some of the accumulating bovine excrement that has wedged itself into the tread of truth, something that is long overdue because it's getting old and mouldy, and clearly the brakes have failed and the flaps are broken and the propellers have fallen off into oblivion. So it's time to lower the landing gear and take a mule into this great chemtrail contrail and deliver some facts into this battle zone, some disaster relief, some social sustenance, if you will. Seems there's many souls who are happy to spend time bathing themselves in the bottomless cesspit of fear porn, absorbing sketchy information of no substance as they pseudo-educate themselves by attending clown school in the social media circus and listening to hysterical verbal vomit spewed forth by spineless and/or deluded amateurs with highly questionable motives. So there's really only one way to mop this mess up and seed some critical thinking back into the equation, and that is through education. Well, it just so happens we know a guy. He firmly stands in truth, with the axe of facts in one hand and a bucket of babbled bleach in the other, and he's ready to scrub the rub. In this episode, our friend Jeff is going to take one such example of gross negligence of facts and explain the what, where, why, and how of the common chemtrail, contrail, plane fart, jet exhaust, whatever your preference. The white lines that trail behind planes that often linger and spread out into cirrus cloud. You know, that thing folks are all up in arms about, who are generally the same folks who don't think twice about booking a flight for their next holiday. That's because they don't understand. The time has come to shut some mouths and open some minds and change the world one lie at a time by arming yourself with a few simple facts in less time than it takes to watch your favourite dribble on Netflix. I mean, you can even speed up the playback if you really push for time, but some things just can't be explained in 1 minute or 140 characters. If you look deeply into something, the information tends to stick, instead of shooting through one ear and out the other and never taking a seat in that great brain we've been blessed with. Think of it this way, a lot of folks are still blissfully unaware of what looms over us, the people. Because as of right now, November 2024, the future of what little freedoms we still grasp onto is in the claws of bloodthirsty, psychotic, self-appointed technocrats who want to pin us and feed us bugs while we blob our lives away in our nosebags of perpetual propaganda. At this very moment, the infamous misinformation, disinformation bills are being drafted and voted upon in the political arena, and every time another post is mindlessly shared with no checking or foundational research done is yet another brick in their wall of oppression. Another reason for them to cement the censorship they so desperately want to inflict on all of us. So don't play the game. There really is no excuse to continue in ignorance, for it is not the bliss that we have been programmed to believe it is. This is information warfare, so get some data-tainment into you. Deprogram thyself. Choose a side, science or psyop. Speculation and misinformed conclusions are low-hanging fruit, easily accessible for amateurs and recycled children with short attention spans. So, it's time to put the big pants on. Let's get skywise. G'day Jeff, how you going, mate?
I'm doing superb. Thank you, Stella. How about yourself?
Oh, I'm superb too. Thank you. So we're going to talk, we're going to do some skywising today and learn a little bit about what causes contrails and chemtrails. Potato, potato. Is that correct?
That is correct. We're going to learn where they are found in relation to cloud shields associated with tropical storms, with low pressure centers, cold fronts, warm fronts. Where do you find jet exhaust trails? People can argue about what they want to call them, but jet exhaust trails, where are they located? And it happens to be the same place most of the time.
All right. lovingly known as plane farts. Shout out Jim
Correcto.
Lee.
Yes.
All right, take it away.
Okay, so two things came into my view in the past day. I got a text from somebody, and I saw this video right here that you're looking at right here, a screenshot of this video showing over Arizona, Southern California. It's showing lines, and this person thinks it's nefarious. The text that came to me, people want an explanation for the things they're experiencing with their eyes. One thing the host brought up was that a couple of days after seeing a lot of sea trails, chem, the weather would change. It'd be useful for Jeff and Stella to put together a short video explaining the weather patterns that cause this thing that people are experiencing. That would give you something to refer people to, and possibly a 10 or 12 word explanation.
Now that's a conspiracy.
That ain't happening.
No, but we'll do our best.
We exceeded that in the first 3 seconds.
Yeah.
Okay, so I want to show a couple of videos here, and this shows satellite photo with cloud top temperatures on the left, and on the right it shows the Radiosonde data that goes with it. So quickly on the Radiosonde data, this shows the temperature curve on the right. It shows that the troposphere tops out at about 200 millibars. This is height on the left. These are meters in this section right here, from surface to about 50,000 feet. That's 16,000 meters. 100 millibars is the pressure value that goes with that, and it increases as you go lower to the surface, which is close to 1,000 millibars. So when you have the temperature and the dew point, that's the second thing. It's a measure of humidity. When they're close together, you get clouds. So looking at the big picture view here, you have a low pressure center west of San Francisco, California, and you have, I want to move this thing out of the way. You've got the Nadine Kristen. It was Nadine when it started over near the Yucatan Peninsula on the Atlantic side, crossed over Mexico, almost fell apart completely, and then reinvigorated itself over the warmer water once it got back over the Pacific. And here it is decaying on the between Hawaii's off to the left and Baja is right here. So this is Oakland sounding, which is right there. This is the Radiosonde data from Oakland. And I want to just show you big picture what's happening here. So I'm going to kind of zoom through it here. And you could see the changes to the moisture on the right. The temperature is on the right. The moisture level is the second line to the left of that.
On the Radiosonde. Yep.
On the Radiosonde, as that hurricane starts to get up to Southern California, which is right there, you can look to the right and see that that area pinches off between 300 and 200 millibars, and that's where aircraft fly, long distance flyers. So
yes, the bulk of the aircraft is in that, the passenger planes, etc., and several others.
Between 30 and 40,000 feet, which is 300 millibars and 200 millibars. And you can see right above 200, the moisture drops off. It separates from the temperature. Temperature warms. That's the stratosphere start. That's the end of the troposphere. And unless you're Bill Gates, you don't fly up here where it's calm. You fly down here with the rest of us.
Yes.
The elitosphere.
The elitosphere is up there, yes, where they don't spill their champagne.
Correcto.
Us peasants get stuck in the turbulence.
Yep, overflying the hurricanes and going around them. So I'm going to go ahead and continue to forward this through, and you can see that the hurricane falls apart, totally becomes disorganized, and all that upper level moisture, and you can watch the changes to the graphs on the right, where that area between 300 and 200 millibars went away at that point. Back it up, right about there. It's still over the Oakland area, which is San Francisco Bay. and it's a really thick layer, and that's
Mm.
like between 25,000 and 40,000, 45,000. That's a 20,000 foot thick layer of dense high and mid clouds.
Lots of
And
moisture.
lots of moisture. So just watch that graph, and around the 28th at 12Z, it disappears. It gets pushed off to the east and disappears off the picture. And that low pressure center offshore is what gave some of the initial moisture, and it goes up towards Canada. So that gives you the big picture view. Decaying hurricane moisture, high level moisture. We are going to be paying attention to the outer edges where it's white, and that
Right.
is
Okay.
cirrostratus areas on the perimeter of that remnants of this hurricane, Kristen.
Yeah, it's amazing when you see it from that sort of view, how much it just really confirms the sky as a river, basically.
It's a fluid.
Incredible.
It's actually kind of beautiful.
It is. Glorious.
Okay, so that's it for that. I'm going to not go, well, let me see. Should I look at Vandenberg? I'm going to skip that one because it's very similar. It just shows that, I won't skip it. It shows a very similar thing to where this is down here where the bulk of the moisture is versus up in San Francisco. So if I zoom through that, I'm going to go ahead and put this thing down here again. There's the hurricane, and you can see that Vandenberg, which is that point right there.
Okay, that's the weather station that this information is coming from, the Radiosonde.
Yes. It's more in the bulk of this moisture here. So I'm going to drag it through, and you'll see it hits that more than it did Oakland right there. And Oakland's on the northern periphery of it. So you could see again right here, super, super tight temperature dew point, which is called the dew point depression. From 500 millibars is about 20,000 feet up to the tropopause, top of the troposphere. And then it moves off to the east as drier air comes in from the west. And that's indicated by the orange and the black areas, at which point everything pushes through. So that's showing you the big picture of the moisture. Okay, so first picture right here, this deals with low pressure, temperate system, low pressure centers. You have warm fronts and you have cold fronts. The warm front is red, cold fronts are blue. With a warm front, you have warm, moist air is advancing to the north. The circulation around a low is counterclockwise, so therefore you have winds that are coming from the south, pushing north. On the west side of a low, you have cold air pushing to the south. And you have another depiction of that to the left, cold, dry air coming from continental United States in this case, and warm, moist air coming from the Gulf of Mexico, pushing to the north. So what you have for clouds with this is with a warm front. Warm fronts are always first. They come in on the east side of the low, warm air pushing to the north. Your cloud types, cirrus, wispy stuff, cirrostratus, sheet-like. If you go back to our cloud video number 4, something like that. And then there was a follow-up that showed more in depth about clouds. You've got the cirrus out front, cirrostratus, altostratus, nimbostratus. The important part here is you got warm air pushing up over colder air, and where that cold air touches that moisture, you get clouds forming. And this is another way to look at the cold fronts. Cold air is coming down from the northwest, and warm air is retreating, and the cloud patterns are very similar. They're different as well, though. You have cold air wedge pushing under the warm air. The warm air is rising up more quickly because cold fronts go faster. And you have cirrus out front, cirrostratus following, and thunderstorms and rain showers at the frontal surface and above it. It's lifting. Any lifting causes cooling. Then you have tropical storms, hurricanes, tropical depressions. And the thing here is everybody knows about the eye. and it's upward moving air at the eye, and the air goes upward, hits the troposphere, cannot go any higher, so it spreads out into a cirrostratus shield. At the edge of that cirrostratus shield is cirrus, the wispier clouds that are thinner. This is very thick, the cirrostratus shield, anywhere near the center and protruding outwards, flattening into a big circle that you see on the satellite photos. Yep. And not so important right here, we're talking about cirrus today, but you got all these rain showers within that. So that's not the point of this. The main thing here is that the massive twisting incoming air rises, becoming colder and drier as the heat and moisture are released. It has to go somewhere, and it goes outward, and it goes outward, and some of it goes back down, and descending air warms. That's why you have an eye. But you got all that cirrostratus and cirrus that have to spread out because they hit the troposphere, the tropopause, and all of them are similar in the effect that you have cirrus and cirrostratus on the leading edge to the east as everything is moving from west to east. So that's the big picture view of where you find cirrus and cirrostratus. And what I want to show you now is the weather balloon network is critical to all this because in conjunction with satellites, you have all these radiosondes throughout the world. And I want to show you why radiosondes are important. They work in tandem with satellites. So 2 times a day, that's the first paragraph. I'm just capsulizing the paragraphs at 0Z and 12Z. And that's your typical times. That's UTC, Zulu.
Right, so that's the UTC. That's so they all do it UTC, so everyone's doing it at the same time. Makes sense.
Correct. And all these yellow dots are radiosonde stations. This is over Mongolia even. You got them in Japan, you've got them in Hokkaido, you got them in the Kamchatka Peninsula. They're everywhere. Moscow. You go to the next picture right here. There's the eastern US and Europe. Next picture. There's South America, Central America, throughout. Cuba does not have one, but Dominican Republic does, Virgin Islands, all these places through the Caribbean.
You think that Cuba would actually really need a couple at least, because that's like smack bang in the middle of the horror show of hurricane area.
You would think, but maybe they just don't want to share. I don't know.
Fair enough. Maybe they're just still a little bit sore about the sugarcane fields. I'm not sure. Anyway, back to Australia. Hello.
And then you got Australia, and you got Brisbane, and you've got Sydney, and you got all over Australia. The whole world is covered with these radiosondes, and they're coordinated. And why? Is because they make the weather maps. They're fed into the weather models to provide the initial conditions for forecasting as often as every 6 hours. Like around hurricanes, they do them more frequently. They're direct measurements as it's passing through. And just so you know, a radiosonde goes up at about 1,200 feet, 400 meters per minute. So it's very quickly going through these spots. They might go through a hole in the cloud. They might go through a center of a big cloud. But depending on where they go is what you get for the readings. It could be at the edge of a cloud, right dead center, or not even close.
Yeah, so there's always going to be those variables, isn't there? And I suppose, I mean, the fact that there's so many of them all around the world, sort of, I guess that kind of fills in the gaps, so to speak.
Exactly, and keep in mind, they're all going up at the same time. They're giving a snapshot in time. So, like for instance, they all pass 30,000 feet at roughly the same time. Everybody's got a little variance in the time that they release, and the stability of the air will make a difference in the speed that they rise. Like if it's a strong inversion, they're going to go up a little slower. If it's really unstable, they'll go up faster. So the point is that you're shooting a gap. You might hit. Here's kind of how I see clouds. I see numbers. 10s in the blues, 15-degree dew point depression. In the center where it's real thick, it's a bunch of zeros. Excuse me. Where that radiosonde goes through depends on the dew point depression that you're going to get. And think of it like this. You almost always have cirrus and cirrostratus in the sky if there's a contrail. Contrail/chemtrail. It's rare to see a contrail without one of them white feathery clouds up near it. Why? A cloud exists because the temperature and dew point are very close together. A cloud has an edge because that temperature dew point difference widens beyond a certain difference. For cirrus, around 60% humidity is all you need. It's different for ice versus water vapor, where you have to approach 100% humidity. When an aircraft approaches a cirrus cloud, it adds moisture from the combustion of kerosene. That narrows the temperature dew point spread because the moisture gets higher from the kerosene. So you get a spike of a linear cloud coming out of the red clouds, the cirrostratus. On some of the views, they're red. In the middle of the thick red clouds, the spikes just get absorbed into the thick clouds and are not seen. They kind of eat the contrail.
Yeah. Although it isn't impossible to see a contrail in a clear blue sky, because I've seen it myself. So I've always assumed, well, it's just going through like a little patch of just the right conditions, which is another reason why they can turn on and off, because it's not the nozzles. It's not the switch on the dashboard being turned on and off by the pilot. No. It's just going through different bands of the correct conditions. Correct?
Exactly. Perfectly said.
Thank
And
you.
if you
You
look
taught
right
me.
here, you got a good teacher.
Thanks for the check, by the way.
This is the leading edge of the hurricane. There's no eye anymore. And you can see the first band is over the desert southwest. And all those blue lines in there, they're at the leading edge in that thinner cirrus. And if you look down below, very thin clouds, blue, just like they show right there. And it would be the same thing somewhere up. If I were zooming on this cold front up here, that's a cold front. You would possibly see clouds or aircraft flying into that mix right there. So in this case right here, let's look at flight radar real quick. This is 1500 Zulu. Let me back up a little bit. Back up a couple frames to around 1200, because that's when the Radiosonde Data was. So this is start of the day. The sun's rising at this point. 12, 26, 12. Oh, I got my filters changed here. I want to put all my filters back on. So right now it's showing Air Force and military, and there's one flight. No.
Yeah, well, this is important. We check this anyway, because people are going to be saying, oh, they're doing this and they're doing that. So we're looking at military.
You virtually have no military in the air right now.
Only, right, okay.
So I got military, government, and U.S. Air Force checked off right now. But I want to check off.
Does this coincide with the time of the screenshot that you took from the video?
Yes.
Okay, beautiful.
So around 12Z. So 35 to 40,000, and where's my 30 to 35,000? And I need to update this. This is the hour after that. So you have a lot of aircraft in the air down there, and they should
Okay, so
show.
What's that airport there? Oh, Los Angeles. Yeah.
Yeah, LAX is right there.
It's another big major one too, isn't it? San Diego. So we've got a couple of pretty major airports on the west coast there, and which is 26. Pretty much right in the thick of where those curious lines were.
So that early in the day, there's not a lot of aircraft right there. I'm going to double check, make sure I have 30 to 35,000, 35 to 40, and 40 to 45. And this is 12 a.m. and I'm going to click forward 30 minutes. The sun is coming in from the right. You can see the lightening of the clouds, and aircraft traffic is starting with the brightness of the day. and you're really busy shortly after. These are between 30 and 40,000 feet, essentially. And if I click off the 40 to 45, get rid of the commercial, get rid of the 35 to 40, and get rid of the 30 to 35, that gets rid of your commercial aircraft, and that's the military aircraft that are left.
There's nothing really there. Okay.
If I zoomed it out, I might see something. There's something up there.
Okay, what's that one?
That's a tanker, a KC-135 Strato tanker, which is used for refuelings. So
yes, the refueling. Yes,
it
that's
came
like an
from
art.
Tokyo and it's going to Riverside. It's landing down by LA. So that guy has no play whatsoever in what's happening down there.
Okay, thank you for that. Doesn't seem to be anything else military looking that is showing on the map, at least.
Tiny little things right here, John Wayne Airport. That might be. It's a smaller aircraft. You can see these are depicted based on the size of the aircraft as well. Let me zoom in a little bit and see if there's anything more down that way. But all that, most of the stuff was over Arizona that we saw in that satellite picture.
Those
so you
lines,
can see there's,
you mean?
Yeah.
Okay.
On that one picture that I showed you. So nothing in the bright yellow color, which says other than that guy right there, that's your only military at that time. And this is 1344. And if I click forward 30 minutes, that guy landed, and click forward another 30 minutes, and you got a little trainer down there. But this is considerably after T-45 Goshawk doing little circles over the desert. There were no high flyers anywhere near that stuff happening out there.
All right then, thank you.
Okay, so last but not least, now we drill into the data and we go to a site that looks like this. It's the University of Wyoming. So we're gonna actually we saw the graphic view of the moisture that was down southwest, and this will show this, which is the same thing that we saw.
Radiosonde from the balloons, yep.
And I want to show you another view of that Radiosonde data, which is on an app called Windy. And this is exactly what we just saw right here. If you look at the little spike there right above 300 millibars, and you look at it in Windy, Windy makes it possible to just put your cursor on it, and it gives you really good data, 33,495 feet, 43 knot winds from the west out of 260, temperature is minus 39, dew point is minus 42, 3-degree spread. So at 34,000 feet, you've got a lot of moisture, and anybody going through that is going to leave a contrail. And all these other areas in here are less than a 5-degree spread. So as you'll see when I drill into the data, the actual numbers, you'll see that when you hit 60% humidity, you start seeing persistent contrails in the data. So that allows you, this site allows you to go anywhere in the world, South America, everywhere. And you can specify the date range of the data. And in this case, the way I did it was, you could see that it changes throughout time right here. And on the 28th at 12Z, it spreads out. That's the morning of the 28th after the thing is passed off to the east. But this windy data is really handy because it specifies all your numbers across that level as it passes that level. That's all your data.
It doesn't get much more specific than that, does it?
It can't get better than that. So that shows the data, but now I want to actually go into the data that I saw. So down here, this shows the data from Miramar, which is San Diego. on the 26th at 1200 Zulu UTC. So I'm going to drill into this, but I'm showing you, I'm highlighting that section of data between 300 and 200 millibars.
Okay.
And when I go into the stuff that I'm going to show you next, I found out, I'll show you in advance what I discovered. When you have 69% humidity, anywhere in the 60s or 70s, that becomes a point where it shows a persistent contrail. And more than half of these have that.
Right.
And this is the temperature of the air on the third column. This is the height in meters. The second column, that's the millibar value on the left. So I'm focusing between 200 and 300 millibars. And that most of these are saturated to where you would have consistent contrails that persist. Now I'm going to go into that data and show the specifics. There's this site called Metabunk, and Mick West built this app to show you whether or not you have a persistent contrail. And this one I have highlighted is the 210 millibar line, 12,000 meters. That's about 40,000 feet, right near the tropopause. And you can tell where the tropopause ends by the coldest temperature. It's actually 164 millibars, 13,000 meters. That's the coldest temperature. Anyway, back to this, it's 64% humidity and a minus 53.1. Enter 64%, 200 millibars, 210 millibars, 53.1. And it says, with respect to ice, it is saturated. So you do these at all of these locations, then this is, here's the calculator. That's his website right there. I'll give you the link for that, Stella, so people can do this.
Thank you.
And it shows that with respect to water, it's only 64% unsaturated, but with respect to ice, it is saturated. Okay, so I want to just go through a few of these. I highlighted quite a few of them that were saturated. And there's 108% saturated. If you plug those numbers in, this one's 102%. This is 106%. This is 109%, 104%. And as you continue to work your way through this, they all meet saturated 113%. This is at 252 millibars, which is dead center of the flight stratum for the aircraft. That's 11,000 meters, about 35,000 feet, dead center. So anybody that goes through this is going to leave a persistent contrail.
Which is where all the bulk of the planes do go, the passenger jets, etc.
Yes.
So there's going to be quite a few contrails, chemtrails, potato.
Exactly. And there they are right there. And every flight that goes up above 30,000 feet is potentially leaving a contrail at
and
the
just
leading
a little
edge.
Yep, just a very small reminder here that contrails and chemtrails, whatever you prefer to call them, they're always up there. We just happen to see them sometimes when the conditions are correct.
Go to see Jim Lee at climateviewer.com, and he covers the specifics of the jet exhausts and what's in them. And when you discover that, it's like, I actually went and got jet fuel from the local airport. I went and got Jet A and did the tests. I drove to the Bay Area and had testing done and got a bunch of non-detects, and I was jumping up and down going, I knew it. It's just ice crystals. Yeah, there are ice crystals, and I've proven it on hundreds of times by looking at the flight radar and checking to see if that stratum that is moist, where the temperature dew point spread is very small, I'll be looking at flight radar and go, that guy's at 35,000 feet. Let's watch him come in. And I can see him before, I see the contrail before, he's 40 or 50 miles away. And hundreds of times I saw this correlation. It's not a correlation, it's a rule.
Yeah, and you've done that in the Telegram group. You've said, oh, there's going to be contrails here. We've all seen it. You've done that.
Yep. My cheat. Here we go. Go to Venture Sky. This shows the upper air pattern. In this case, this is the wind speed at 200 millibars.
This is the
So
jet stream we're looking at here, isn't it?
yeah, this is set for the time. This is 26. If you look up here, 2615Z. Let me go back one more. This is 2612Z. You got Kristy out here. You got a big high pressure center behind it. There's a high pressure ridge going up into the western US and Canada. You got that low pressure center that we saw is moving to the northeast towards Canada. There's a trough extending to the south. And then you got another ridge out there. So that jet stream is indicated by that maroon color. It goes around the lows, counterclockwise, around the highs, and it outlines the ridges and the troughs. So you got a ridge right here, and that moisture is coming from Kristy, going around the high pressure and into the southwest. Then it dives back down, way down into Mexico, and then comes back up towards Florida. So that's your jet stream. But for clouds, if I want to see what's coming the next day or two, go to high clouds. And that shows what it was that morning. That white area is exactly, not exact, but very close to what we see. And if you just play that through, you can click hour by hour if you want.
What does the white indicate? That's a cloud, is it?
That's your cirrus clouds, your high clouds. Okay. That's where they're going to be found.
Gotcha.
At this time. So if I just start zooming forward a day at a time. So looking at the West Coast, LA area has got a patch there on the 30th. There's more coming through and cold fronts coming in from the west. That's a low pressure center south of the Aleutians. This is a decaying cold front with a low pressure center up off of Vancouver Island. And you can just play this through and have an idea when you're going to have contrails. You have a possibility if there are cirrus clouds showing on this. So go forward, don't go beyond a week. It becomes less accurate as time goes on. But for tomorrow, where are you? Click on the date and you'll know if you have a possibility of contrails happening.
That is actually something that gets to me a little bit, is like we can't really be sure about what's happening much beyond a few days, 7 to 10 max pretty much. I mean, the weather people all admit that themselves. But yet they know what they're doing with geoengineering.
Wait, Stella. You can't go a week out for a good, solid forecast, but they're going to tell us what the Earth's temperature is going to do 50 years from now, 20 years from now.
I know. The hypocrisy never ends.
How's that work?
Oh, I don't know. I would love to know. It works because they have their very fancy schmancy simulations and computers telling them stuff, which just depends on what's put into it, really.
Garbage in, garbage out. We have Radiosonde Data every 12 hours. In an ideal world, you would have these guys more than 150 miles apart. If you look right here, let's look at this Miramar one, and they tell the next closest ones, California Edwards, 150 miles. Yuma, 158 miles. If I click on Texas, I see the next one, 162, 203. If I go to, that's probably what? At Jacksonville, 193, 155, 196. If we wanted more accuracy, you make more Radisson stations.
Yeah.
And
yeah, it's much more fun to play with the balloons. I mean, it's, way more accurate. It's instant.
Instantaneous data. They could do them every 6 hours if they wanted more accuracy. And this tells a whole bunch of data about the flight. Just picking one randomly here. This one got to a maximum height of 80,757 feet. It was launched at 11:07 Zulu time. Let's go to Arkansas.
11:07. Was it? I thought you said that they only did them at 12 and 12.
Well,
0 and 12.
They time it. They're all about the same time. So They call it 0Z because it's up in that part of the atmosphere at that time. At 30,000 feet,
Oh, okay.
it takes 1,200 feet a minute, so 25 minutes. Let's look at this right here. Which one did I just click on? Yeah, right here. Go in closer. You could see 12 hours ago,
Little Rock.
elevation's 568 feet. That's Little Rock field. It was launched at 11:11. It got up to 80,000 feet, and sometimes they actually tell you why they terminated. Let me just click on that one. 53,000.
They
This one got
terminate
up.
them?
Yeah, it tells the reason why they ended. Why?
How do they do that?
Usually it's balloon burst.
Right, okay. Gotcha.
Usually it just expands so large that the balloon bursts.
Yeah, okay. Because the higher it
gets
goes, the balloon gets bigger and bigger with the less pressure.
Yes.
Yeah.
And there, let's see, weight, they tell you the gas weight, 1 kilogram, frequencies,
right.
all the data right
Oh.
there, tracked by GPS, 54,000 feet. Anyway,
It's a lot of info. Yeah, it's good.
that would be an interesting one right there. You've got Lee clouds happening down there over.
Yes, it's not scalar waves.
And not scalar waves, they're Lee clouds due to the
Doppler or
winds.
whatever else.
Moist winds going over rough terrain.
I was there once. And then I got learned.
Got learned. So does everything that I just told you make sense, Stella?
Certainly does. It always does. Do we want to just sort of circle back?
Circle back.
Circle back to the other gentleman's video and just.
There we go.
Okay, so it is totally normal. Thank you for.
Take it away, Stella.
Well, I mean, it's been put there in plain neon pink. This is totally normal. So well done, because it is. So, yep, those lines there are all chemtrail contrails because of the conditions being correct near a couple of rather busy airports around the altitude that lots of planes fly. And it's on the very edge of this storm where there's lots of cirrus clouds and the conditions are correct. So it sort of stands to reason that would be expected. And you'd probably be able to find exactly the same thing if you had a similar system and had a look over the last however long this technology's been going.
Yep.
Past, future, whatever. In fact, yeah, it's worth. I mean, people should be looking at this stuff. Stop listening to these twits on social media and wherever they're saying, "Oh, they're doing this and they're doing that." Check it for yourself. That's why we're here. That's why we're doing this. We're trying to teach you how to. Oh, I'm trying to learn myself how to check all this stuff with our own discernment, not listening to it secondhand through these filters, these BS filters, or ching filters, whoever it may be. So that all makes sense. Are we pretty much done with that now?
We are. I was hoping to get one more satellite picture up, but it looks like it's not gonna. It's not really responding very well right here. My internet's not doing great for the second. So
no worries. Well, I think that's probably covered everything fairly well. Do you think?
It does. Shows where the cirrus is in relation to low pressure centers, warm fronts, cold fronts, and tropical storms. And that's where you're going to see any aircraft going into that area is going to leave a trail.
Yep. Yeah, it's just a matter of sort of understanding the physics. I was going to say science, but it's such a last millennium word now, isn't it? Sort of like PSY ents.
It got ruined.
Yeah. They sabotaged yet another word. But anyway, so when you understand the science behind it, or the physics, or the way it all works, the A's, B's, and C's, 1, 2, 3s of it all, it's all quite logical. And it's all dispelling a lot of not only misinformation, I'm going to call it. It's not disinformation, because I think these people are just purposely being ignorant and getting clickbait. So it all makes sense when you understand what's behind the systems of our world, our great planet.
Nicely said.
Would you agree? Yes. All right. Well, yet again, I do thank you for bringing some logic into the equation of this particular ether.
Pleasure.
And,
Thank you.
We're going to step on these bugs with our stilettos of truth. Well, maybe not you. You can you can wear your work boots. But thank you everybody for joining us, and we hope that this has been somewhat enlightening, if you're still here. And we look forward to bringing more truth and data-tainment your way in the very near future. So thanks again, Jeff, and take care, everybody. Bye-bye.
Bye-bye.